Let's continue looking at distributions in the center of a distribution, but in this case, let's look, in part 2, let's look at issues of mean versus median. In particular, which is larger? And the first case is when you have a symmetric distribution. When you have a symmetric distribution, that means that the mean will equal to the median. Now, perfectly symmetrical distributions, the mean will equal to the median. So let's say it's not exactly symmetrical, let's say it's almost symmetric. If it's almost symmetric, then roughly the mean will equal to the median. And in fact, we can turn this away, and an easy test for symmetry is, does the mean equal to the median? And if the mean and the median are fairly similar, then probably it's roughly symmetrical. That doesn't have to be. And if the mean or the median is much larger, then it probably won't. It won't be symmetrical. Now let's look at a skewed distribution. And again, the easiest one to think about is U.S. income. And I'm not picking on the United States. If you look at any advanced country, in fact, any country in the world, it would have similar income, but that's just the income that we know the best. And income in the United States looks roughly like this. Let this be X and this be the probability of X. So this is how much people make, and this is how many people make that amount of money. So there's some people that make very little money, a lot of people that make kind of a low to middling amount, and then it decreases after that. And of course, Bill Gates is way out here. Okay, I'm roughly about here, I think. All right, so let's think about U.S. income. If you think about median U.S. income and mean, the median is going to be that number where half of them fall on one side. So this might be the median, whereas the mean might be somewhere here. Now I've exaggerated it a little bit, but the key here is the mean will be greater than the median. And that's always going to be true when you have a skewed distribution if it's skewed to the right. Well, did I say always? I meant to say usually. This is a pretty good rule of thumb, though you can come up with counterexamples where it's not true. But for the purposes of introductory stats class, if it's skewed to the right, that likely means that the mean will be greater than the median. And how do you remember this? The way you remember this is there's an old joke, right? And the old joke is there are 20 people in a bar. And Bill Gates walks in. And average income rises, right? Kind of a stats joke, it's not that funny. But the idea is if there's 20 people in a bar, the way you get the average income is you add up their incomes and divide by 20. If Bill Gates walks in, then you have 21 people in the bar. You add up everyone's income, including Bill Gates, which is probably $40 billion. I don't know. It's a lot. And then, of course, the average income is much larger, right? And we can think of it as a simple case, an example. Let's say you have an average of 5, 6, 3, 4. So that's, let's make this work out even. 5, that's 18 and 2, right? So that's 11, 18, 20, so that's 21, 2, 3, 4, 5. So the average is 4, right? Now let's add 100. So you have 5, 6, 3, 4, 2, and 100. Now the average will be 120, right? I think that's right. 11, 14, 18, 20, 120, 1, 2, 3, 4, 5, 6. 120 divided by 6 is equal to 20. So if you notice what happens is you add one number which is very large, the average goes from 4 to 20. Whereas the median didn't really change very much. 2, 3, here the median would be 4. And here the median, 2, 3, 4, would be 4.5. Let's do skewed to the left. The easiest way for me to remember it is memorize skewed to the right. Remember, skewed to the left is just the opposite. If you have skewed to the left, you have something that looks like that. Then in that case, what you would have is you would have the mean is less than the median. The median might be here, and the mean might be something like here. Again, what I would recommend doing is memorize this one or the Bill Gates joke, and memorize that if it's skewed to the right, that means that mean is greater than median. Let's do this really quick. Symmetric, skewed to the right, skewed to the left. Let's do a little table. In symmetric, that means mean is equal to median. If it's skewed to the right, that means the mean is greater than the median. And if it's skewed to the left, that means the mean will be less than the median. And I'm going to put a little memorize guy up here. And you should either memorize that straight or memorize why it's true. And that's part 2 on center of a distribution.